Welcome to Math with Malia. Today we're doing Savvas enVision Algebra 1, Topic 7, Lesson 4, Factoring Polynomials. You can think of this as the reverse of multiplying polynomials. We're just going in the reverse direction. So how is factoring a polynomial similar to factoring integers? Well, as we saw with multiplying, it's following the same rules. We're going to look for what's called the greatest common factor, just like we do when we're factoring integers. So let's review really quick. If we're going to do the prime factorization of the coefficients of this polynomial, 12, 8, and negative 6, we're going to factor 12. So 12 is just 4 times 3, and I can break down 4 into 2 and 2. Now those are all prime numbers, so this is the prime factorization. I can break down 8 into 4 times 2, and again I can break down 4 into 2 times 2. And 6 is just 2 times 3. So now we can look at what do they all have in common. They all have a 2 in common, okay? So since they all have 1, 2 in common, they all have a factor of 2. That is the greatest common factor. That is the largest number that they all have in common. So we can do the same thing with the variables. We're going to take x and we're going to break it. We're going to decompose it, expand it out. Same with x to the 4th and x to the 3rd. Now, how many do they all have in common? Well, this one has 3. Do I have 3 x's in each one? I do. I have 3 x's in each one, so the greatest common factor of the x variables is x to the 3rd. And then if we multiply those together, the greatest common factor for the polynomial is 2 times x to the 3rd. So all we're doing is we are doing the distributive property in reverse. If I were to pull out a 2 and an x cubed from this polynomial, then I would be able to multiply it by factors inside to get my final polynomial. So we can think of it as doing the distributive property in reverse. So 2x cubed times what will give me 12x to the 5th. So 2 times what gives me 12? Well, 2 times 6. X to the 3rd times what gives me x to the 5th? Well, I already have 3. How many more x's do I need? I need 2, so I need an x squared here. Okay, let's do the same for the next one. What times 2x cubed is going to give me 8x to the 4th? Well, 2 times what gives me 8? 2 times 4, and it's going to be a positive 4. I already have x to the 3rd power. I need 1 more to get x to the 4th. And for our last term in our polynomial, what times 2x cubed is going to give me negative 6x cubed? So this is important. Watch the signs. 2 times what gives me negative 6? 2 times negative 3 will give me negative 6. I already have my 3 x's, so I don't need a variable in that last term, in that last factor. So when we pull out the greatest common factor, then we are factoring our polynomial. We're breaking it into 2 polynomials. We have a monomial times a trinomial, but it will give me an equivalent expression. So first we're just going to practice finding the greatest common factor for these terms. 15 and 18. Notice the second term, the 18, does not have an x variable, so x is not a greatest common factor. There's no x in the second term, so we can ignore that one. What are the factors of 15? Well, I've got 3 and 5, and I've got 1 and 15. Probably not going to be 1 and 15. What are my factors for 18? I've got 3 and 6, and I've got 2 and 9. What do they have in common? They both have a 3, and that's it. So my greatest common factor for A is just 3. No x factors. For part B, let's look. Okay, they all have a y, so I know y is also a common factor. So what's the greatest number of y's that each term has? Well, each term has at least 2 y's, right? So I can pull out a y squared. And now we're going to look at the numbers. Negative 18, 6, and 24. So let's look at the factors of negative 18. You can ignore the negative for now. So what are the factors of 18? We can break it down. 2 and 9, 3 and 6. What are the factors of 6? 1 and 6, 2 and 3. And what are the factors of 24? 1 and 24, obviously. 2 and 12, 3 and 8, and 4 and 6. So what do they all have in common? Well, they have a 2. They all have a 2. But is that the greatest common factor? They also all have a 3. Is that the greatest common factor? Nope, they all have a 6. So the greatest common factor is 6, y squared. So why is it helpful to factor out the greatest common factor from a polynomial? We're breaking it down into a simpler form. So just like I showed you, we can get it to a factored form. So as I showed you in the previous example, once we break it down and pull out the greatest common factor, then we do the distributive property in reverse. And this can be helpful for solving for x. We're going to be doing that in topic 9. So it helps us to get a polynomial with smaller coefficients, smaller exponents. This makes it easier for us to analyze the polynomial or even to factor it further, and we're going to do more work with that in future lessons. So let's factor these. We're going to pull out the greatest common factor and then do the reverse distributive property. Okay, so looking at A, they all have an x, so I can pull out an x. Now I'm going to write my parentheses, and I'm just going to distribute in reverse. X times what gives me x cubed? Well, I have 1x, I need 2 more. Okay, then I'm going to look, x times what gives me 5x squared? Well, I need to do, remember there's an invisible 1 there, so I need to multiply it by 5, and I need 1 more x. For the last term, this is also going to be positive. For the last term, what times x gives me negative 22x? Well, 1 times negative 22 will give me negative 22, and I already have my x, so I don't need to have that in my third term. Part B. Let's look. First, let's pull out the variable. So they have at least, all of them have at least 3 y's. It's really easy for the variables. You just take the one that has the lowest exponent, and that's your greatest common factor. You pull that one out. So the least exponent is y to the third, and so that's what I pull out. Now let's look at our numbers, 16, 28, and 20. You might need to break down the factors. So I've got 2 and 8, I've got 4 and 4. For 28, I've got 2 and 14, and I've got 4 and 7. For 20, I have 2 and 10, I have 4 and 5. What's my greatest common factor? 4. Okay, but notice one of the terms, or actually 2 of the terms is negative, so let's factor out a negative 4. It's always helpful so that we have positive terms inside our parentheses. So let's factor out a negative 4. Add my parentheses, and I'm going to do the reverse distributive property. So negative 4y cubed times what is going to give me negative 16y to the 6th. So first look at the number. Negative 4 times what gives me negative 16? I need to multiply it by 4 to get negative 16. And I have 3 y's. How many more y's do I need? I need 3 more y's. Okay, for the next term, negative 4y cubed times what is going to give me positive 28y to the 4th. So negative 4 times what gives me 28. So since it's negative, I have to multiply it by another negative number to get a positive 28. So that would be times, or minus 7, multiplied by negative 7. I have 3 y's. I need 1 more y to get y to the 4th. For the last term, negative 4y cubed times what is going to give me negative 20y cubed. So negative 4 times positive 5 is going to give me negative 20. So make sure you include your signs. And then I already have my 3 y's. I don't need to add any more. So again, make sure you pull out the negative when you're doing your greatest common factors. Factor out the negative 1 so that your first term in the parentheses is going to be positive. We don't want to have a negative term right at the beginning of our parentheses. Application, factoring a polynomial model. So Alani is in charge of marketing for a travel company. She's designing a brochure that will have 6 total photos. The photos can be arranged on the page in a number of ways. There are two main squares of photos which have a length of x on each side. So let's write that. This is x, and this is x, this is x, and this is x. There are four narrower photos that are each 1 by x. So this side is 1 and this side is x for each of those. Okay, this side is 1, this side is x. So we can figure out the area of each of those pictures. So what's the area of each type of photo? So for the square photo, the area is x times x, or just x squared. And we have two of those. So here's our expression to represent the total area of the square photos. The narrow rectangular photos, 1 times x is x. How many of those do I have? 4. So 4x is going to be the expression to represent the narrow photos. So for the whole total area of the brochure, we have this expression, 2x squared plus 4x is the total area for the whole brochure. So find a rectangular arrangement for the photos. What factored expression represents the area of the arrangement? So if we place the photos all in one row, one long rectangle, whether or not the narrow photos, all 4 come first and then we follow by 2 square photos, it doesn't matter. So all in one row, the height we know is still x, but we have, how did we get this 2x plus 4? Well, because this is 1, this is 1, this is x, this is x, this is 1, this is 1. If we add them all together, we get 2x plus 4. So then if we're talking about area, it's just length times width. So our area would be represented by x times 2x plus 4. This is in factored form, right? We want to leave it in factored form because this piece will tell us one dimension, and this piece will tell us another dimension. So we want to leave it in factored form. So this is one arrangement. What if we arranged it vertically and we stacked them into 2 rows? Okay, so now what's the total length? Well, remember, this length is x. So x plus x is 2x. And then this is x, this is 1, this is 1, so this becomes x plus 2. There's my dimensions. And I'm going to write the area again. The area is just one dimension times the other dimension. And again, I'm going to leave it in factored form because they tell me the different dimensions. Each piece of factored form tells me a dimension. So in this case, the greatest common factor is going to represent the height of one possible arrangement. It's either going to be a height of x, 1 square, or it's going to be a height of 2x, or 2 squares. Which of these two arrangements is a more practical use of the space on a page of the brochure? So do we want to have it lengthwise, or do we want to have it stacked 2 rows, 2 square pictures on top of each other? Well, probably the second arrangement, because we can more likely fit that on one page than having to have a brochure that folds open to show a longer picture that doesn't take up as much space above and below. Try it number 3. Suppose the dimensions of the narrow photos were increased to 2 inches by x. What expression would represent the new arrangement based on the GCF? So again, if we're going to have, and then 2 of these, and then we have another one. Sorry, this is not very square. Okay, but now this is x, this is x. This is now 2, and this is x. This is 2, this is x. Okay, x, 2, 2, and x. So what is the total height? It's going to still be 2x. What is the total length going to be now? It's going to be x plus 4. So if we're going to represent the area, 2x times x plus 4 would be the new dimensions if the length is increased to 2 inches. We made it to the concept summary for factoring polynomials. This is a skill you want to have down pat. So make sure you know how to factor, looking for greatest common factors of the numbers, the coefficients, and looking at the variables. The variables is easy. You just look for the least exponent for each of the variables. But remember, each term has to have the variable. In this case, the last term does not have a y, so you cannot pull a y out in the greatest common factor. And then after you pull out the greatest common factor, then you just do the distributive property in reverse to find out the simplified polynomial inside the parentheses. You'll see how we're going to use this more in future lessons. If you have any questions, put it in the comments. Make sure to like and subscribe and come back for lesson 5.